Let's now solve this using velocity time graph. This is another question that's a bit comprehensive. A body at rest. In the velocity time graph, when a body is at rest, it means the journey begins from the origin. So that means this point is where the body is initially. Given an initial uniform acceleration of 8 meters per square seconds. What does that mean? It means that it accelerates at this 8 meters per square second for 30 seconds. So I'm going to indicate a point on the time axis to represent 30 seconds. And since acceleration is 8, I cannot put it on this vertical axis. Why? Because the vertical axis here is meant for velocity. The line of acceleration, please take note of that, is always like this under velocity time graph. While the line of deceleration or retardation is like this. This is acceleration, this is deceleration. So now I need to draw something like this now from here. How do I do that? I will pick a point on the vertical axis that will represent the new velocity the body is going to have, having accelerated at 8 meters per square second. Because anytime acceleration takes place, velocity increases. So velocity will increase from 0 to another value unknown, which I will use V1 to represent. I'm using, let me use U to represent that. Now, having done this, I will now trace this 30 up and this U horizontal. Wherever they meet is the new position of the body. So the body starts from here and is here now. So you join the 2 points together, and that line is the line of acceleration, which is 8 meters per square second. All right. After which the acceleration is reduced to 5 meters per square second. Please take note of this. Acceleration being reduced does not mean deceleration. Yes, acceleration is acceleration. That is increase in velocity per time. While deceleration is decrease in velocity per time. So that means the only thing they are telling us here is that the acceleration rather has changed from 8 to 5. So that means there will be another velocity. There will be another velocity reached. Let me call it V. Why would there be another velocity reached? Because, like I said the other time, anytime a body accelerates, it will surely bring a new velocity on the increase. That is, a higher velocity will come in than the initial. So, the time given is 20. I'm going to add 20 to 30 to make it 50. So I will trace the line of the new velocity, which is V. I will trace it horizontally. I will trace that of time vertically. So where they meet is there. Can you see? So that means I'm going to join another line from here to here. If you look at that line also, you can say that is a line of acceleration, because I told you acceleration is always like this. So you can see it's not horizontal. It has to bend. It will slope down from right to left. That is acceleration. Why from left to right is deceleration. All right. Now, having done this, that means from here to here is 5 meters per square second. The body maintains the speed attained. What is the speed attained? That is V. Because this is the new velocity now. It's no longer U. It was U here. But here it is V. So it maintains. When it maintains, what does that mean? It means it does not change. And that is what we call constant velocity or uniform velocity. And whenever a body is moving with a constant or uniform velocity, acceleration will be zero. Therefore, the line drawn must be horizontal. That is to show constant velocity. It cannot be inclined because there is no acceleration. For how long? For 60 seconds. It maintains this velocity for 60 seconds. So I'm going to add 60 to 50. That will be 110. So that means I will trace the 110 to the front of this V. So this is it. So I'm going to join these together. So you can say that this is a horizontal line showing that the velocity is still V. If you trace it to the vertical axis, it will still be on V. After which it is brought to rest in 20 seconds. When the body is brought to rest, it means it comes back to the horizontal axis. So that means I will add 20. I will add 20 to 110. That will be 130. So brought to rest means it decelerates to rest. So because when the body is brought to rest, it means that the velocity will fall, will decrease. So the velocity is decreasing from this value to 0, because if you trace this point on the horizontal back to the origin, it is 0. That means the velocity is 0 here. So let me label this point A, B, C, D, E, F, G, H. All right. So this is the diagram for velocity time graph for this question. So now, what are the questions we are asked to find? The first question says we should find the average retardation. Sorry, the maximum speed, rather. The maximum speed. Okay,